For centuries, imaging technology has been transforming how we see the world, enabling us to look beyond the limits of eyesight, making the invisible visible, uncovering a treasure of data, information, and insights. With technological breakthroughs being more frequent than ever, cutting-edge technologies like multimodal imaging and artificial intelligence are propelling the field of imaging engineering forward at an incredible pace, opening up incredible opportunities to transform the fields of medicine, biology, agriculture, chemistry, material science, automation and production, and more. And the best part? The imaging revolution has just begun. Imaging allows us to study the building blocks of life, from tissues and cells to molecules. This deepens our understanding of molecules' interactions and the structures of materials. They allow us to study how pharmaceutical chemicals interact with cells, or how the different layers on an artist's painting age at the molecular level. Imaging technologies and methods are changing how we look at health and disease. Think of an MRI scan to measure brain activity, for example, revealing the structure, function, and activity of our brains. Innovating how we produce our food and assuring its quality with hyperspectral imaging, for example, which enables us to visualize and identify crop diseases. Whether it is imaging the health of crops in a field, looking at the stars in the sky, or at cells through a microscope, it is the engineering and technological advances behind imaging instruments and techniques that allow us to tell a story of what is going on around us. As you can see, the applications of imaging are widespread, effective, and truly transform human life. But what's next for this multidisciplinary field? How will imaging engineering help the planet and our society to become more healthy, sustainable, and safe for generations to come? As technology advances, so does the field of imaging engineering, and the possibilities are endless. In the years to come, new technologies and innovations will enable scientists and engineers to unlock new layers of detail at different scales, gain new insights, and develop state-of-the-art imaging strategies. Imagine doctors able to remotely perform surgeries thanks to extremely high-quality 3D images and robotics. Imagine researchers being able to study the polymerization of new materials for biomedical applications, or engineers designing improved vacuum systems, lasers and optical systems, or sensors to sharpen the functionality of existing imaging technologies. Imaging engineering will turn all of these future possibilities into a reality. The field of imaging engineering requires a new generation of imaging scientists and engineers. A professional with an interdisciplinary skill set, trained to tackle a wide spectrum of challenges that society faces. A bridge builder that is able to push the field of imaging forward by bridging the gap between imaging research, instruments, and applications. Imaging engineer, professor, and director of the Maastricht Institute for Molecular Imaging M4I, Ron Heren, will tell you why there's such a need for imaging engineers.
My name is Ron Heren. I'm a university professor of molecular imaging here at Maastricht University, and I'm the director of the Maastricht Multimodal Molecular Imaging Institute, M4I, or short, Maastricht for Imaging. How do I see the future of imaging engineering? The future of imaging engineering is incredibly bright and challenging because there's a huge need for new imaging technologies. There's a huge need for analytical technologies that all need to be developed in the future. In order to develop those, we need new young professionals that can take their knowledge across the different disciplines that contribute to imaging engineering. Whether it's physics, chemistry, biology, those new professionals need to combine all this knowledge in the design of new imaging technologies. So the future of imaging engineering is with you.
The future of imaging is a bright one, and so is your future as an imaging engineering graduate. As the imaging engineering field keeps growing, so does the demand for highly trained engineers on the labour market. Thanks to the multidisciplinary nature of the program, you will be able to push the frontiers of instrumentation or molecular imaging engineering on areas such as microscopy, mass spectrometry, pharmaceutical and base chemical industry, biotechnology, agriculture and food industry, and more. As a graduate, you have multiple options. You can dive straight into a career in industry, or perhaps you're more interested in pursuing a PhD. Maybe you would like to start your own company or feel more at home in the public sector. The future is yours. Let's hear some more about your future career possibilities.
So if you ask me, what career opportunities do imaging engineering professionals have? My answer is simple. They're huge. There are so many skills and competences that you will learn that find their way into industry and society. You can actually be the person who designs a new analytical instrument or a new microscope with a microscope company. You can actually be a person that develops new technologies in the hospital to come up with new patient diagnostics. Your career could be in an academic institution where you be the one that designs or contributes to the design of a new satellite or a new telescope that flies into outer space and observes the origin of life. All of these broad application areas will find their way into your career as an imaging engineering professional. The Master of Imaging Engineering has an industrial advisory board. And this industrial advisory board helps us to ensure that we keep a connection with the needs of science, society, and industry. And companies like Bruker, Thermo Fisher Scientific, Philips, ASML, they are all in need of these imaging engineering professionals. With them, you can engage in research projects that will actually define your career of the future.
The imaging field sits at the crossroads of engineering, mathematics, physics, and chemistry. What is most important is that you can communicate and collaborate across these disciplinary boundaries. This is exactly what we offer you at Maastricht University. With us, you will get the opportunity to explore and step into your expert role within the field of imaging engineering. At the same time, you professionalize your communication and collaboration skills to make a real difference. We are Maastricht University, the most international university in the Netherlands. We are a student-centered university, which means our students' needs and quality education are our top priority. Our teaching methods are unique within the Dutch academic landscape. We also offer you access to cutting-edge facilities in a research-rich environment. Maastricht has its own Imaging Research Institute, the world-leading Maastricht Multimodal Molecular Imaging Institute, or M4I. In the Imaging Engineering Master's Programme, you are taught by numerous researchers involved with M4I and other research groups in the Faculty of Science and Engineering. You have access to M4I's state-of-the-art facilities, technologies and expertise in areas such as cryo-M and mass spectrometry and Skinexis's ultra-high-field MRI. You will thus study right in the middle of a highly inspiring environment. But that's not all. Our program distinguishes itself by its unique teaching methods. We use both problem-based learning and research-based learning. Problem-based learning, or PBL in short, is all about working in small tutorial groups and attending far fewer lectures. Under the supervision of a tutor, you team up with 10 to 15 students to discuss real-life problems and challenges. Your tutors are very approachable, and you learn together in an active way, helping to form you into an assertive professional. Research-based learning, or RBL for short, involves researching complex imaging challenges and designing technical solutions in a small project team of fellow students. RBL simulates the day-to-day working environment in which engineers operate, optimally preparing you for your future role as a technical professional. Our program director will tell you more about what makes our program so unique.
My name is Julia Massimeli Subel. I'm an associate professor in the Faculty of Science and Engineering. And I also serve as program director of 3 interdisciplinary master programs, including the Master of Imaging Engineering. In my view, what makes this program so unique is 3 aspects. Number 1 is the fact that it's interdisciplinary, so students can delve deep in the disciplines of physics, engineering, mathematics, and chemistry or biochemistry, therefore crossing interdisciplinary boundaries. The second aspect, I think, is the small class setting. So it's a lot of opportunity for interaction between students and also between students and the teachers, and also research and industry partners. And lastly, I think the aspect that makes this program quite unique is the fact that it is designed with an education modality that is quite collaborative. We use problem-based learning and research-based learning.
The Imaging Engineering program is interdisciplinary and focuses on 4 main disciplines: engineering, mathematics, physics, and chemistry. You will take courses on all of these topics. Here's why.
The Master of Imaging Engineering is actually designed around the disciplines of engineering, mathematics, physics, and chemistry. And in order to combine these disciplines in a new field of imaging engineering, students at the very beginning of the program need a common basis or introduction into, first of all, the field of molecular imaging and engineering. They need a basis in instruments and technologies. They need an introduction into molecules and structures. And also they need some basic knowledge or introduction into the informatic aspects related to actually collecting and managing data that come from imaging instruments. Therefore, in the first semester of the program, students actually take courses that actually provide this common ground. And then, after the first semester, students can actually choose an emphasis or a track in molecular imaging engineering or instrumentation imaging engineering that will suit their interest.
Let's look at the outline of the first year. The program starts once per year in September. Each year consists of 2 semesters, which are divided into 3 periods each. In the first 2 periods, which last for 8 weeks each, you take compulsory courses. After the first 2 periods, you'll work on a research and engineering project full-time for 4 weeks. During research projects, you work as a group with around 5 to 7 other students. You design technical solutions to real-world imaging challenges by applying the insights you've picked up during previous courses and skills training. Everything, from research to reporting to project management, is in your hands. But that's not all about the research projects.
Our curriculum also incorporates research projects. And these research projects are up to you to design. Of course, they fit within the curriculum. If you have an interest more in the instrument engineering traject, then you could, for instance, think about doing a research project on building a vacuum system of a new mass spectrometer. If you are more interested in the molecular engineering side of things, of imaging, then you could actually engage in a research project designing new probes to develop and to visualize proteins that are involved in a certain disease. Combined, these 2 research projects will help you to develop the new tools of the future. New tools for medics, new tools for material scientists, new tools for astronomists, new tools for academic and educational professionals in the Netherlands and beyond.
At the end of your first semester, it's time to choose your specialization track in either instrumentation imaging engineering or molecular imaging engineering. In the instrumentation imaging engineering track, you learn to use, design, and optimize existing and new imaging instrumentation to drive the field forward. In the molecular imaging engineering track, you learn to bridge the gap between molecular research and suitable imaging instruments in order to adequately obtain and validate research results. During the second and third semester, you follow courses related to the specialization of your choice, and you choose elective courses to shape your curriculum. Each semester ends with a research project. The 4th and final semester is all about the grand finale, an internship, and your master thesis. You can choose to do your master thesis at a company, research institute, NGO startup, whatever fits your ambitions. The choice is yours. If you would like to know more about the curriculum and the courses, please visit our website. Are you excited to start this program? To enroll, you need a bachelor's degree in a relevant field. Let's hear which backgrounds are a good fit.
The Master of Imaging Engineering is designed for students with a bachelor in engineering, mathematics, chemistry, physics, biomedical sciences, or related fields that have an interest in either learning how to operate, design, and engineer imaging instruments, or they have an interest in molecules properties, interactions, and other aspects that are related to imaging engineering.
Most importantly, you need motivation. Motivation to study across disciplines and to be challenged academically. Our master's program is taught in English, which means proficiency in English is required as well. Our Board of Admission assesses every application individually. Additional information about admissions, including our pre-master, can be found on our website. So, will you be a good match for this program? Time to find out. Details on the registration and admission procedure can be found on our website.
This program is a great match for students that have technical interests. If you are a geek that likes working on a car but want to have a career in academic engineering, this program could be a fit for you. But if you're interested in more biomedical imaging and want to define the new diagnostics of patients in the future, you could also fit. So in other words, students that have an interest in developing their technological, chemical, or biological skills with a very strong engineering accent would benefit from this program.
That's it from us. Thank you.